Hi, welcome to a video about completing the square. Now, it may have been a little while since you've done this, but completing the square is just taking a quadratic equation that's in standard form and turning it into vertex form. That's all that it is. If you remember back in AGS 2 about Optima Prime's quilt shop, that's what completing the square was all about. That's what you learned during that entire unit. So I may be referencing that. You may see me drawing pictures, but if you don't like the pictures, that's okay. We will mostly be doing this numerically. So I just have 3 problems just to kind of get us started to remember how to really complete something, and then we'll do a few full completing the square problems. So first, let's take a look at number 1. Let's see, find the value of c that completes the square. Now, when we're talking about completing the square, we are talking about a real physical square. So if we have r squared minus 36r plus c. So if I think about this as an actual square, I'm going to create myself a box. We're going to have the side lengths of this box, or let's say quilt, of r by r, giving us r squared. Okay. Now we have negative 36r. So if I take that negative 36 and I split that in half, that's going to give me negative 18. So this is going to be in this box over here. That's going to be, negative 18r. And over here, negative 18r, giving us a total of negative 36r. You can really think about the standard form of the quadratic, really like the area of something. So this is the area of this square. And you can also think of the negative 36r as like little pieces that looks like this that are r length by 1, and we've just shoved a bunch of them together, if you prefer. So we have to actually complete the square, meaning what goes right here? Well, if we're thinking of area, this is r by r, or r squared. Negative 18 times r, negative 18r. So this would be negative 18 times negative 18, or in our case, that's going to be 324. So that's all we're looking at. So we can say that c is equal to 324. Now, if you don't want to draw the whole square and go through that whole process, you don't have to. If we take a look at number 3 over here, if I take my b value, in this case of just a positive 24, and split that in half, that's going to get me 12. And then if I take that 12 and I square it, so 12 times 12, kind of like what we did with the negative 18 times negative 18, that's going to get me 144. So I can say that c is 144. You can also think of this as we took the b value, split it in half, and squared it, and that got us our c value. So if you prefer to think of it that way, that works as well. I'm going to be leaving problems 5 and 7 as homework practice. So let's continue on to the next type of problem. So here, just trying to get all the instructions, find the value that completes the square and then rewrite as a perfect square. Okay, so we're taking an extra step from what we have. So we still have to find the c value, but now we have to put it into a perfect square. So for us, let's take a look at number 9. If I use the same process that we did before and I cut this in half, well, I'm like, ooh, that's an odd number. If I cut it in half, that'll be a fraction. Okay, so it's a fraction. Who cares? So you can handle that, I promise. So let's see. If I change my pen color and I draw my square, I'm going to have x and x, giving me an x squared inside. And then if I take that b value of 5 and I split in half, I'm just going to leave that as 5 halves. I'm going to leave this as a fraction. So this will give me a positive 5 halves x. Here another positive 5 halves x. And then if I multiply 5 halves by 5 halves, that's going to get me 25 over 4. So we know that's supposed to go here. So that's what we did in our previous problem, but then it also asks us to rewrite as a perfect square. And what that means there is our side lengths So if I take these side lengths here of x plus 5 halves times x plus 5 halves, that's going to get us our answer of x plus 5 halves squared, because that's how you find the area of a square. You multiply two of the sides together. And there you go. So that's what it's looking for. Let's do one more like this, and then we'll get on to some real completing the square. So if we take a look at problem number 11, if I was to say, whoops, okay, let's take negative 32 and split that in half. That'll give us a negative 16. And then if we take negative 16 and we square that, that's going to give us our C value of 256. So we know that right there, that's going to be our C value. And then if it asks us to write in our perfect square, what does that look like? Well, we're going to be using this length right here. So we took our B value and split it in half. Whatever we have left over, that ends up being our side length, or extra side length. So in this case, our answer is going to be x minus 16 squared, with an x minus 16 being the side length of our square. So I'm going to be leaving problems 13. I think we'll just do 13 for another homework problem. Let's get to some real completing the square. Here, the directions are simply solve each equation by completing the square. So I'm going to go through, I think, 4 examples of completing the square with you, just to show you a variety of what could happen. So the first thing I'm going to do is I'm actually going to add 10 to both sides. You always want to start when your equation is equal to 0. So 18v plus 32. Now, some teachers might teach you to subtract the 22 on both sides and go from there. That is also a valid method. This is just my way of doing it. If your teacher taught it differently, that's totally fine. Just make sure that we're still getting the same answer. So from here, we've done so many practices of just finding a C value. So that's actually what I'm going to do, is I'm going to rewrite this problem like v squared plus 18v plus something, I don't know what, plus 32 is equal to 0. Because then I take a look at this and I'm like, oh, these are just like the problems that we did. I already know how to do that. So let's go do that. So let's see, C is going to be found by taking our B value of 18, splitting that in half and getting 9. Now remember, whenever we take our B value and split that in half, that's going to be our eventual side length. So I'm just going to write that for myself. But then let's take that 9 and square it and get 81. So that's going to be our C value. So we're going to have v squared plus 18v plus 81. Now, fun fact, you can't just like start adding random numbers into equations. You have to balance it out. So for adding 81, I'm also going to be subtracting 81 to make sure we keep the same value. I'm going to add 81 inside the parentheses because that's going to be my perfect square. But on the outside of the parentheses with this 32, that's where I'm going to subtract the 81. So I'm just adding 81 and subtracting 81. It's still going to equal the exact same thing. I just have to make sure that I balance it out. So the plus 81 is for the perfect square. And I can draw that. So we've got v squared plus 9. So we got positive 9v and a positive 9v. And then in here we found 81. So we're putting a positive 81 into that perfect square inside that parentheses. But again, I have to balance it out. So from here, we have one last step. We need to make it look different. So just like what we did for problem number, I believe it was 11, inside the parentheses, we're going to make that look like a perfect square. So we're going to say that this is v plus 9 squared. So everything inside the parentheses, instead of looking at it like an area, we're now looking at side, oops, sorry, I thought that was the highlighter. There we go. Side length by side length. So v plus 9 squared. And then on the outside, we have a positive 32 minus 81, and that's going to give us negative 49. And that's what completing the square looks like. This is our final answer. Yay! So let's try that once more. Let's try problem number 18 together. So let's see over here. I'm going to make this a little bit smaller. There we go. Okay. So let's see, number 18. I'm going to start by adding 8 to both sides. So we have n squared plus 4n minus 77 is equal to 0. And then, again, you don't have to take the step. I like to just take an extra step to make it look like the problems we've already done. So we're going to do n squared plus 4n plus some number, I don't know what, minus 77 is equal to 0. And then from there, I got to find out my c values. I'm going to take 4, split it in half. That'll give me 2. Remember, that's going to be the side length, or the extra side length of my square. Let's take that 2 and square it to find our c value of 4. So we're going to have n squared plus 4n plus 4. Now remember, I can't just start adding random numbers because I'm adding 4 here on the outside with the negative 77. I'm also going to have to subtract 4 to keep that balance. So if I'm adding it in one place, I have to subtract it into another. So my very last step here, remember everything inside the parentheses I have to write as a perfect square. So I'll write this as n plus 2 squared, since 2 is my side length. And then let's see, negative 77 minus 4, it's going to give us a negative 81. And there is our problem. So I'm going to be giving you a few problems like this to practice in the Go formative. But let's go an extra step. What if it's not just v squared or n squared? What if there's an a value greater than 1? What if it's like 7 or something like that? What do? We're going to do 2 problems just like that. Starting with problem number 23. We're going to do problems 23 and 25, and then we'll be done. Yay. Okay, so problem 23, taking a look here, we have 7k squared by itself. You can subtract 7k squared on both sides and then set it equal to 0. However, that also makes the a value negative, which makes things way more exciting. So instead, I'm going to subtract 14k and 29 on both sides, giving us 7k squared minus 14k minus 29 is equal to 0. So my first step I'm going to do it just like what we have been doing and kind of kick out that negative 29 to be 7k squared minus 14k plus some number minus 29 is equal to 0. And then from there, so instead of just having, I'm going to drop my box, instead of having a k and k with a k squared, pretend I've drawn this box 7 times, and that's essentially what we have. So dealing with 7 boxes seems like a lot, so I'm going to factor out the 7 out of just the 7 and the 14. Now that I know that I'm just focusing on my perfect square, I'm not going to worry about the 29. So I'm going to leave this as 7 times k squared minus 2k plus some number minus 29 is equal to 0. This way I can focus just like what we've been doing. I can focus on this one square. So what I'm going to do is I'm going to take this negative 2, our b value, split that in half, and get negative 1. Remember, that's going to be our side length. So in our actual square, I'm going to write negative 1 and negative 1, because that's going to be negative k minus k. I'm going to take that negative 1 and square it and get positive 1, or as we can see in this square right here. So when I rewrite my next step, that's going to be 7 times k squared minus 2k plus 1. Now here's where things get tricky. So I know that this is right here. I just needed one little square to complete my completed square right here. So I needed one of these. But remember, we don't have just one of these. We in fact have 7. So if I'm saying, hey, I'm using a 1 here, I need to balance that out, it's really not 1. It's 1 7 times. So I'm going to take whatever number is out here, multiply it to my c value that I just used to complete my square, and that's what I'm going to use to balance it out. So instead of saying minus 1, I'm actually going to say minus 7, because I'm not just borrowing one square, I'm doing that one square 7 times. And now I write this like we do everything else. So we'll keep the 7 on the outside. You don't have to multiply that back in. And then we're going to take a look at the side lengths of our square. In this case, k minus 1 times k minus 1, or k minus 1 squared. And then negative 29 minus 7 gives us a negative 36. And there you have it. So hopefully you'll notice there's not too many extra steps when you have an a value that's greater than 1. But you just have to remember, oh right, there's more than one square that I'm currently completing. So let's try problem number 25 and then we'll be done. So let's see, in this case I'm going to add 2n squared to both sides and then subtract 1 on both sides. And it's going to get me, 4n squared plus 16n minus 70 is equal to 0. I'm going to do what I've always done and kind of kick out whatever c value I have. So I'm going to have 4n squared plus 16n plus some number minus 70 is equal to 0. And now I'm going, okay, it's not just 1n squared, there's 4n squareds. So I'm going to kick out the 4 and factor that out. So it'll be n squared plus 4n plus some number minus 70 is equal to 0. So really my goal is to make it look as similar to the first few problems that we did. And so far we've done that. So now that we've done that as much as we can, I'm going to take that b value of 4, split that in half to become 2. Remember, it's our new side length of our square. If you'd like to draw the square, you could do that, but you do not have to. And we're going to take the 2 and square that. And that number 4 goes right there. That's our new c value. So we'll write that as 4 times n squared plus 4n plus 4. Now remember, we're adding 4 to one of the squares, but we're adding this 4 times. So when I'm balancing it out, instead of writing minus 4, I'm going to write minus 16. Because again, I'm adding those 4 pieces 4 times. So multiply this number here to this number here to balance it out over here. And then our last step, let's see, we'll do 4 times our side length squared. So this will be n plus 2 squared. And then negative 70 minus 16 is going to be negative 86. And there you have it. I'm going to give you a few more problems from this page on your Go Formative. Let me know if you have any questions.